if we know position vectors of any 3 points in the plane, then we can write equation of line in vector form. Suppose A, B, C are the 3 points with position vectors A bar, B bar and C bar. Then we can write equation of line, equation of plane in vector form. But these 3 points, they should be non-collinear. They should not lie on same line. A and B and third point C. So we can observe that points, they are not collinear. Join AB and AC. Now consider any other point in the same plane other than these 3 points A, B, C. Suppose R is a point. Join AR. Now we can draw vectors through these points. So AR bar, AB bar, AC bar. These are the 3 vectors. And we have to write equation of plane in vector form. These 3 lines, they are in the same plane. Now to form equation of plane, we want a vector which is normal, perpendicular to plane. Then AB bar cross AC bar, cross product of 2 vectors, is a vector which is perpendicular to AB bar and AC bar. Means it is perpendicular to plane of AB bar and AC bar. This is a vector normal to the plane. Cross product of 2 vectors is a vector quantity. It is perpendicular to plane of AB bar and AC bar. So it is perpendicular to each line or each vector in this plane. Therefore, AR bar, it is perpendicular to AB bar cross AC bar. 2 vectors are perpendicular to each other. It means that their dot product, scalar product is 0. AR bar dot AB bar cross AC bar equal to 0. AB bar, AC bar, AR bar, they are vectors in space. Vector in space can be expressed as position vector of terminal point minus position vector of initial point. AR bar, A initial point, R terminal point. So AR bar, R bar minus A bar. We shall write that in bracket. Dot AB bar, A initial point, B terminal point. So in bracket, position vector of terminal point minus position vector of initial point. Cross in another bracket. AC bar, A initial point, C terminal point. C bar minus A bar equal to 0. Here cross product is there. So we have to write this expression in bracket. R bar minus A bar dot. Simplify expression in this bracket. Open these round brackets. In cross product, order is important. So B bar cross C bar minus B bar cross A bar minus A bar cross C bar minus minus plus A bar cross A bar equal to 0. R bar minus A bar dot B bar cross C bar. In cross product, order of vectors is important. Dot product, order of vectors not important. A bar dot B bar same as B bar dot A bar. But A bar cross B bar and B bar cross A bar, they are not same. Their signs are opposite. B bar cross A bar, we can write A bar cross B bar. But in that case, we have to change sign of term. A bar cross C bar, that we shall write C bar cross A bar. Cross product of collinear vectors 0. Cross product of vector with itself 0. So A bar cross A bar 0 equal to 0. So we have used properties of cross product. R bar minus A bar dot. Rearrange the terms. In addition of vectors, order not important. A bar cross B bar plus B bar cross C bar plus C bar cross A bar is equal to 0. In a plane, if we know position vectors of any 3 points which are non-collinear, then we can write equation in vector form. Instead of that, if we know coordinates of any 3 non-collinear points in a plane, then also we can find equation of plane. But that equation, it is in Cartesian form. Suppose coordinates of 3 points in plane A, x1, y1, z1, B, x2, y2, z2, point C, x3, y3, z3. Equation of plane in Cartesian form. In that equation, determinant is there. In determinant, in first row, x minus x1, y minus y1, z minus z1. In second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Now here observe elements in second row of determinant. Difference between corresponding coordinates. It means that in second row there are direction ratios of line AB or vector AB. In third row there are direction ratios of line AC or direction ratios of vector AC. Now we can find equation of plane which is passing through intersection of two planes. Now these are the two planes intersecting each other. In case of intersection of two lines, we can observe that there is only one common point between them. So intersection of two lines is a point only, whereas intersection of two planes is a line. Now this is a line which is present on both the planes. It is intersection of two planes, and through this line we can draw infinite number of planes. Equation of plane passing through point A bar, and normal to the plane N bar. Then equation of plane R bar dot N bar equal to A bar dot N bar. Right hand side dot product of two vectors, scalar quantity. So we may denote it like this: R bar dot N bar equal to D. Right hand side scalar quantity constant. Here there are two planes. Their equations we may write: R bar dot N1 bar equal to D1. Equation of other plane: R bar dot N2 bar equal to D2. Then equation of plane passing through intersection of two planes can be written: R bar dot in bracket N1 bar plus lambda N2 bar equal to D1 plus lambda D2, where lambda it is a real number, scalar quantity. So when we know equations of two planes in vector form, then we can find equation of plane passing through intersection of those two planes. Through intersection of two planes, we can draw infinite number of planes. Lambda changes for each plane. For different values of lambda, we get different planes. Intersection of two planes is a line, and through that line, infinite number of planes can pass. Now we have seen equation of plane in Cartesian form. If P is distance of plane, perpendicular distance of plane from origin, and direction cosines of normal to the plane LMN, then equation of plane Lx plus My plus Nz equal to P. Instead of knowing direction cosines, if we know direction ratios of plane, then equation of plane may be written Ax plus By plus Cz plus D equal to 0. Here A, B, C, D, they are the real numbers, constants. If we want equations of two planes in this form, then coefficients we shall write A1, B1, C1, D1. Equation of other plane: A2x plus B2y plus C2z plus D2 is equal to 0. Equation of plane passing through intersection of those two planes can be written as A1x plus B1y plus C1z plus D1 plus lambda into bracket A2x plus B2y plus C2z plus D2 is equal to 0. And this is equation of plane in Cartesian form.